we're now going to kick our synthesis up a degree, and what we're going to do is add in the utility of the diazonium ion, first to allow us to access additional substituents like FCN and OH, which we couldn't do before. But secondly, it's going to allow us to prepare substituted benzenes without forming undesired isomers. So there's a few tips to keep in mind. The first is one that we've talked about a couple of times, and that's that the bulky amide group of acetanilide can block out the ortho positions. So if you have this group, that's going to block out those ortho positions. So we can add that group on and take it off. The second thing has to do with having a para-amino group that can block that position, but it can subsequently be removed. So we'll see this when we do some example problems here in a bit. But let's say you have an NH2 group here. Well, with that group there, you can't add anything to this position para to the R group. So that will allow you to kind of block that site out. But remember that amino groups can be converted to the diazonium ion. And with the reagent H3PO2, we can convert that diazonium ion to a hydrogen, effectively removing the amino group. So if you need to temporarily block a certain position on the ring, you can do that with a nitrogen, and through diazonium chemistry, end up removing that blocking group. So that's something we'll use. The other thing to keep in mind in terms of directing group abilities, because a lot of times we're dealing with nitrogens, remember that nitro is a meta-director. So if you need to group directed meta, do it while the nitro is on the ring. But that nitro group can easily be converted to NH2 by a reduction, and NH2 is an orthopara director. So when you're adding groups, do it at the appropriate time with the appropriate group on the ring. In this first synthesis problem, we're starting with benzene. We want the tetrasubstituted benzene. And something that should jump out to you immediately is the fluorine that's on the ring. We don't have a way to directly install fluorine, so we need to do that through the diazonium ion chemistry. And remember that before you ever get the diazonium ion, you're going to have an amino group. And when that amino group is on the ring, you can do the tribromination. So let's do that. We're going to start with benzene. And we need to get the amino group on the ring. So the way we would do that is start with the nitration. That will give us the nitro group. Next, we need to reduce the nitro group to NH2. I'll do that with hydrogen and palladium on carbon. So let's draw out that structure. Now we have the NH2 on the ring. This is a strong activating group that when we halogenate, it's going to trihalogenate. So now we can add Br2. We don't even need the catalyst. So we have our 3 bromines on the ring. From here, we need to get to the fluorine. To do that, let's convert the amino group to a diazonium ion. We use sodium nitrite and HCl. From here, now we can convert that to the aryl fluoride using the reagent HBF4. And there's our final product. In this synthesis problem, we want to prepare the tri-substituted benzene from benzene, and it is important to note we want to do this without isomers. So we want this to be the sole product of the reaction, which makes it a bit more complex. So let's think about a bit of strategy here. If we have an amino group up here on the top of the ring, that amino group can be eventually converted to a chlorine by diazonium ion chemistry. The amino group will allow us to trichlorinate, putting a chlorine here, here, and here. But we don't want a chlorine down here. So is there a way to temporarily block this position? So here's our strategy. What I want to do is put an amino group up here on top of the ring, add a blocking group down here. Then I want to chlorinate and then convert the amino to a fluorine and remove the blocking group. So that's the basic strategy. We just need to figure out the sequence to do this. So let's start by getting the amino group on the ring. I'm going to use benzene. Going to first do the nitration. And then I'm going to do the reduction. So now I have aniline. The next thing I want to try to do is get my blocking group in place. But how can we selectively get something down here? Well, what we need to do is hinder these positions so I can selectively add something at the bottom of the ring. We can do that with the amide group. So let's add acetic anhydride as the reagent. That blocks out my ortho positions. And now I can do a nitration to get a nitrogen group at the bottom of the ring. So I've effectively added my group that blocks that para position. Now let's go ahead and remove the amide to get back the NH2. I can do that with acid and water. From here, now I'm ready to chlorinate. So in this case, I'm going to go ahead and add my catalyst, just because since I have this deactivating group here, that's going to slow the reaction down a little bit, perhaps. So just to hedge my bets, I'll add the catalyst. It's not a big deal if you don't add the catalyst because you see the NH2, that's fine. So that will do the dichlorination. Okay, next I need to choose my strategy carefully. So what you don't want to do is go ahead and convert this into an NH2, because then you would have two NH2 groups that would react the same way. So if you did the diazonium chemistry, whatever you did to one would happen to the other. So let's deal with this one first, then we'll deal with the one on the bottom. So for the NH2 group on top, what I'm going to do is convert that to a diazonium ion. And then I can convert this to a chlorine using copper chloride. Now I have the three chlorines where I want them. I just need to get rid of that nitro group. How can we do that? Let's first convert it to the amine. Then we'll convert it to the diazonium ion. We'll go ahead and draw that out. And then finally, we can remove that completely. H3PO2. And we get our final product. So this is a long and complex synthesis, and it may seem like a lot, but what I will tell you is as you start to practice some problems, you're going to see this similar strategy over and over again. So frequently using this amide group to block the ortho positions to install something down here, frequently using this nitro as a temporary block that in the end you just remove, or you could convert to something else depending on what you want. So with this, don't let the overall number of steps intimidate you. Just practice several examples, and this is something that I find most people get the hang of pretty quickly.